This is the first part of the meeting for part 7. Apologies for the lack of interaction for the first half of it. I forgot to hit record, so this is just me going back in time. So this one is looking at maintainable programming and looking at arrays as well. So let's see, these are some of the bits. I'll just skip past these slides as it's something fairly similar to the previous kind of sessions. Just a quick reminder that we use the prim method. Again, I won't go too much into this, but please feel free to get in touch if you've got any questions about it. So the first bit that we were looking at is just introducing the 4 main areas for maintainable programming. So this is looking at using comments, using subprograms, as well as using indents and using meaningful variable names and just meaningful names in general for anything that we have to name. One of the kind of bits that I did press upon when I was doing the meeting earlier on is that one of the bonuses of using Python to coding is that it forces you to do indents automatically, and so you kind of get into that habit, and it just makes it a little bit tidier. Other languages allow you to remove the indents and use things like curly brackets to show where loops and if statements will work, but obviously that extra indent just makes it even clearer as to where the code is running that is part of a function or part of an if statement or a loop or whatever it might be. Python uses the hash symbol for comments, and obviously these aren't then run by the program. And one of the things that I do teach the students right from the very beginning, as much as possible, is to use these very meaningful variable names, although at the time I don't talk to them about it then because it makes code more maintainable. The idea of maintainable code is that it should be easy for others to read and interpret, but also for yourself to go back to and read and interpret later on. A number of times I've written a program where I didn't comment it very well, or I didn't make it very easy to read, and it just takes a lot longer for you to be able to work out what you're supposed to be doing. So it is good practice as well as something that we're teaching. So this is just an example of what we're looking at. So this is where I'd also introduce the fact that this is a procedure. So the reason that this is a procedure is because it's not returning any values, it's printing something which just displays it to the screen. When we talk about returning values, we're talking about being returned to the rest of the program so that can then be used later on, or with another subprogram later on. It's really important to make sure that they understand the difference between them. Obviously this one is a procedure. One of the things that we look at when I'm teaching this is to make sure they get used to the structure of it, the indents in there. And so within here, we're actually using all 4 of the maintainable coding techniques. We've got the comments, we've created a subprogram, in this case a procedure. We've also got meaningful variable names, so password for the user's password. And obviously we've got indents that Python makes us do as we go through. Something I do point out to the students as well is that the comments are not run, and so I can show them how to comment out a line of code and see what happens. So it might be something that they then investigate a little bit further. Another part that I get them to focus on is the fact that we've got this double indent for this print, and obviously that double indent is needed because it's to show that the print is part of the if statement, which is part of the subprogram that we've created. And so then I might get them to do something along these tasks, so changing the subprogram so that it runs the subprogram again. And obviously this can then make a loop without using any of the kind of the loops, if you like. So we're using a form of iteration without actually using a for loop or a while loop. And you can do that by adding in your call of the function or the subprogram, again after the print statement. And obviously we can call this as many times as we want to. We also had a brief look at the make task, which is just to have a check of whether a string is long enough, but it's doing a similar sort of thing, so repeating itself if it's not long enough. And obviously this is quite a useful technique. Sometimes you want to get something else to happen, run another function if they get something wrong, or have another go if they get something wrong. We then looked at kind of a larger problem, and this larger problem is made up of multiple subprograms now. So we've got 3 different procedures in here. These are all still procedures because nothing is being returned. The first procedure is just running 2 other procedures. And so the program, as it reads it in, will look through all of these subprograms that have been created, realize that they all exist, and then when it gets to main down here, this is where it will call our main subprogram, our main procedure, and then it will run dog walks, which will then run these lines of code, and then it will run car washes, which will then run these lines of code. One of the things that, again, I get students to focus on here is where I'll look at introducing variable scope. And the idea that variables are only accessible within a specified area. So global variables are ones that can be used throughout a program, and local variables can only be used within a certain part. And so this idea is trying to get them to create an overall total based on the dog total and car total variables, and realizing that they can't do it because the car total can't be accessed from the dog walks procedure, and the dog total can't be accessed from the car washes procedure, and neither of these can be accessed from the main procedure. And obviously that could cause issues later on. So procedures are generally used when there's a kind of final output or a final task to be completed, and there isn't any further use for the data within there. One of the other things that I get them to think about is whether it matters which way round these programs have been written in. So can we write dog walks first and then car washes and then main last, and does it work, providing we don't move where the main call is. And so those are all things to have a look through. And then I give the students an extra task based around there. So this one is very similar. They just add in an extra section, so an extra procedure, this time looking at cakes that were sold. And then the make task is just about getting them to create some code where it uses 2 different methods for counting up to 10. Again, it's just looking at getting them used to creating just some very simple procedures that are just doing things, and they're not necessarily there to return data later on. This now joins the original meeting halfway through. Then obviously this is where I then start to introduce functions now, and so obviously this is where they can start to see the difference between a procedure and a function. And so we've got exactly the same kind of technique at the start to define it. Now I'm going to introduce something else as well, called parameters. So the parameters are bits of data that a function needs in order to run. And you can use parameters with procedures as well. There's no real reason for me missing it out, other than I've kind of rushed through things a little bit. So you can still use parameters in a procedure as well if you want to. And the idea of this is that we can then run this function with any piece of data that we want, and they're just passed in as variables. And these actually become local variables within this function. So the parameter number 1 is then used as the variable number 1, and the parameter number 2 is used as a variable called number 2. And then we have got a return statement, which then makes this a function rather than a print, which would make it a procedure instead. And so when it comes to kind of programming with students and getting them to realize if they're ever asked to write a function, then there must be a return statement at the end of it. And if they're ever asked to write a procedure, then it will probably be there's a print or an output at the end of it. Does that make sense?
Yeah. That makes sense, but I've got a question. But
that's fine.
But I'm still writing.
That's right.
If there's a function, there needs to be a return.
Yeah.
Okay, so here's my question.
Yep.
Brace yourself, because I don't even understand the question I'm about to ask.
They're always good.
Sounds like life generally, doesn't it?
So, right, using your prim method.
Yes.
Of prediction.
Yeah.
What does the following code? What the following code does? Trace the algorithm line by line and explain the overall purpose.
Yeah.
Okay. So the first line, line 1, define add function.
Yes.
Yeah. So we are creating a function called add function.
Yeah.
And that add function takes two variables, num1 and num2. It doesn't do anything with it. It just has. It just says that there are two numbers coming.
Yep.
And then the answer is equal to the two variables together.
Yep.
And then it returns the answer.
Yeah.
But at no point in time here, in lines 1, 2, or 3, does it ask for any numbers. It just says the numbers will come and that they exist.
Yes.
So then in line 5, it says the total. So you're now within this, you're out of the function now because the function stops at return.
Yes.
So then it says total equals add function. So you're calling the function or you're using the function within total. So the total is equal to add function 3 and 7 and then print the total. Yeah. So at no point in time, it doesn't matter what the user does. As soon as they say run this program, it's going to print 10.
Yes. Yeah, so so this one is one where it will do the same thing every time because there's no user input in this one. But what I could do is, and I can't remember if I do actually deal with it, we'll find out in a moment. What I could do is have some inputs beforehand. So I could create two inputs that I use before I call the function, and then I use those variables inside and to replace 3 and 7, so then it will work with whatever numbers the user types in.
This is the first time which I had done something like this in a public lobby.
Does that make sense?
Mm-hmm.
And so the idea is at the moment just introducing the fact that we've got these bits that are data. So we've got these parameters here that says, right, I need this data to be able to run. And then obviously if they don't type in anything in between the brackets, Python will give it an error message. And then we have to then pass them on. And when we pass them in, so when we call the function, we call them arguments. Okay, so we're giving it two arguments to then use. The argument 1 is the number 3, argument 2 is the number 7. Okay, so they're parameters when we're declaring it, and they're arguments when we actually pass it in. Does that all make sense?
I'm never going to remember that, but yeah, okay.
It's something you'll get used to. So I'll try and keep talking about it in that way, and then hopefully it'll go in. So when we're dealing with the print statement, we're giving it the argument total, so that it's got some data to use. But when the print function is defined, it's obviously got a parameter that it needs, and obviously the print statement can have lots of different parameters as well. It's a bit of a weird one. So then kinds of things that I'd get them to think about here is obviously what the parameters are. So I'd get them to just tell me the two parameters that are used in the subprogram. So we'd have So obviously number 1 and number 2 are the 2 parameters.
Golf course.
What does the total store? So you mentioned it would be storing 10 every time with this one. Then I've got a little bit of a challenging one to see if you get your head around. So what happens if line 7 is changed so that it's printing total plus add function 5, 6?
Add function 5, 6.
Oh.
So everything else runs exactly the same, but
21.
just line. So we'd have 21, yeah. So we'd be adding obviously 5 and 6 together, and obviously that total would be added onto the initial total that we've already got. And the idea of this is just to show that in most cases, when we run a function, we want to assign the data that's returned to a variable so that we're storing it so we can use it later on. But in some cases, we might just want to do something with it straight away. So we could just print it, we could pass it into another function or whatever it might be. And that's what I'm doing with this kind of line there. Does that make sense?
I'm so sorry, Ross. This was my dream of all life. So
and then if line is 3 is deleted,
our show. So needless to say, the
what
lobby
might happen?
happy with this individual.
The program won't run because it's got nothing to return. And
so will none of the program run?
Well, it definitely won't be a function anymore because it doesn't have a return.
Yeah.
And so it's just going to print. No, it won't do anything because add function won't be defined.
Guys, I'm getting loads of interference at this end.
Oh, hey.
There's something else running in the background at someone's house.
Yeah, possibly there's something. I can hear something, yeah.
Maybe just mute your mic because I can't hear what's...
Maybe it's my kids, maybe.
All right.
Yeah, possibly. So yeah, what I'll just go through and I'll just put this in. I'm just going to do it a little shorter. So very short version of it. So when I run this, hopefully it shall do something. My computer's crash. So what's happened? I don't know if that's just going to double check. There we go. That's what should have happened. So what's happened here is that it has printed something, but obviously it's printed none, and that is because this procedure we've written doesn't return anything at all, and so when it's done, it doesn't do anything, and because we've run something, it just says that there isn't a value, so it's just a none value, and that's something that's a little bit kind of unique to Python. And so something is actually written. So the program will run and it will do something, but it won't obviously do what we've intended it to do. And so it's obviously a good opportunity to talk about things like logic errors. Does that make sense? Any questions about that at all?
Can you do this whole lesson over again? It was all very complicated.
Yeah, where do you want me to start?
Oh my gosh. I don't know.
Just with this bit that I've just been going through.
Well, I think, hang on, I kind of got lost around, well, not lost, but I don't think I'd be able to explain. I don't think I'd be able to explain that at all.
This bit.
No, I don't think I could.
So the idea of this is that what we've got is I don't need to make it that big. So we've got this subprogram that we've written here. Because we're not returning anything, and then what we get t equal to is going to be a none value or a null value. It's nothing at all. And so we've then got the print. When we try and print t, all it's going to print is none. This section will run, and if I just go through in debug mode, and we'll just go through it kind of line by line, hopefully. So if we step into this, what we'll see is obviously we're going through and we've got the next line of code. We're saying we're going to use this add function with the numbers 3 and then number 7, and then we're going to step into the function or the subprogram that I've created. And as I go through, I see we've got n1 is 3, n2 is 7, as we'd expect it to be, which means that A is then going to use 3 and 7 as we planned.
Is that kind of like an array?
No, these are just two different variables, and this is just something. Have you ever used a debug mode on Python at all?
Not really.
So it's really useful for being able to kind of read through and see what's happening as you go through. So you just step through each line of code, and it tells you what's going on. And obviously, it's then said, right, we've got back to here, and there's a none value. And then when we print that, we're then printing none, and that's obviously what's displayed at the end. And you can do that obviously with any programs, and it shows you the values of the variables and things as you go through. Different versions of Python and IDEs do it in slightly different ways, but they all kind of have that same result, and that just helps to kind of be able to show exactly what's going on at each point. Does that help at all?
Yeah, maybe you might need to go over that again on Monday.
Yeah, that's fine. So that's that part. And then kind of the idea after that is then kind of getting them to change it. So it's going to multiply some numbers instead. And then the make task is where I get them to or get them to do one where the user types in the number to begin with. Okay. And obviously that's just getting them to go through with that. Any questions about that at all? No? Excellent. And then this is the next part that I'd kind of move on to, where I'm starting to get them to look at arrays. And so arrays are really important for the students to understand. I think from what I can see, there's going to be a question based on arrays in all of the Component 2 papers going forward, because it's something that is a really useful thing to be able to do. And so what I then do is I then try and make sure that as many of the programs afterwards use functions and procedures as we possibly can. So this one is going to use one. It's just doing a simple search. It is just a linear search, but I don't talk to the students about it being a linear search at this point. I've just got them to just have a look to see if they can understand what's going on. And the main focus here is the array. What you do need to realise and understand in Python is that they don't have arrays as they technically should be. So an array is a data structure that has multiple values, that they are all the same data type, and they're always a fixed length. Python. Can
you say that again, please?
Yep.
A data structure that has
it's multiple values.
Hang on, sorry. Wait, Yep, same data.
So same data type, and they're a fixed length, so they have a fixed number of items in there, and obviously they're assigned to an identifier, and that's really key as well. One of the biggest mistakes I think students make is that when they're asked to talk about an array, they'll say an array is a variable that stores multiple pieces of data.
So the array, when you say fixed length, that means that I have to say how many things are going to be in the array before I make it.
Yes.
So where do you say that in this here? So you haven't said.
In Python, so there's different ways of doing it, and in all languages you can do it in this way. So in Python, we have to do it in a kind of clever way. So Python actually just makes use of lists, and lists are similar to arrays, but they can have multiple different data types, and they can be variable in length. And so whenever I'm doing it with the students, I'm talking to them as though a list is an array. And that's where it can get a little bit complicated, because you'll have some students that go out and say, well, I can do this with this list or this array, and you're saying you can't. And that's because how Python works. There are add-ons to use actual arrays, but they're more complicated to teach them. So what I will just talk about, and I tend to introduce it to students as I introduce the arrays, the fact that what we're going to be using in Python is technically a list, but we are using it as an array, just so that you can get an idea of how it works. And so with this one, when you create an array, some languages will allow you to say, right, I want you to create an array with 5 spaces in them, and then you add the data to it later on. But you can also add the data to it straight away, which is what I've done on line 8 here. I've created an array called words, and I've stored 5 different words in that array to then use.
So where would you then say how many items are in the array?
So you don't need to say, so if you just say, I'm going to create an array and I put in hello world, computer science and Mildenhall in there, then the array knows that there's 5 items.
And if the data that I put in there was numbers, so 1, 2, 7, 9, 15, would I still need to use the quotation marks if I wanted them to be right?
So if they're numbers, obviously they'd be in there as numbers, just like you would with anything else. So if it was a variable, you'd write about speech marks, and for most fit points, it will always be exactly the same as a variable, apart from the fact we've got these different these multiple different values in there rather than just one value.
So so before, turn the page, before when you're talking about making maintainable programming, you have to give your variables proper names that people can understand. So then you change, and this is the thing where I get so confused. You say for I.
Yes, I is one that is kind of a programming standard. So it's just short for index. And if you look at any programs, when it comes to for loops, it's completely acceptable to have I as your incremented value or your index as you go through.
So what could you call it?
So I could call it just value. Or something on those lines in this case, so I'm looking through different values, or I could call it words, although I've got a word one there, so I wouldn't want to do that one. So I'd probably call it value as instead if I didn't want to call it I.
And let me go through this again. So we're making a function. We are making a function. It's a function because it's going to return a position. So then it says that the function's called find. Right. And then it's finding in array. And array is not declared until line 4.
So it's used on line 4, but it's not declared there. The array, so the array is words, so that's what it's using. So it's not actually got any values until we get to line 10.
Then I don't understand line 1.
Okay, so line 1 means I'm creating a function called find, and it needs a piece of data, and when I'm using it within this function, I'm going to call it array.
Hey, when is this thing supposed to come?
Does that make sense?
No.
So what we've got is this idea that we've got this value that we're saying we need to have this value. So a little bit like if we go back to here, we've got these values, number 1 and number 2. I don't actually kind of use those values or say what those values are until this point here. And it's exactly the same here. So I've kind of created this array called array, but I've not actually assigned any data to it. I'm just saying you need to have some data that's going to be given the identifier array when I'm using it.
Okay, so when to find,
Yeah.
you need to find array.
Yeah.
And then I could have put poo in there and it would have just had to look for something called poo.
If you did put that there, then obviously you'd use that here, and you'd use it here as well. This is the.
So where are you actually making?
Where are you at?
Hold on a second.
Son, they can all hear you back there and I can't hear them. Please, can you be quiet? Right, they're saying they can hear feedback. I can't hear.
Sorry, I'm just talking to Daddy. This is why I want to be upstairs, so I don't annoy anyone.
Don't have children. Just don't.
Brilliant.
Oh my goodness. Right, so.
Oh, it's so funny.
Yeah, okay. Kids say.
Right. Hold on 1 second, please.
That's all right. No worries.
Cool.
Is everyone else following this all right, or is there anything else anyone struggling with at all?
Right. Okay.
Thank you, Martin. Yeah, just yeah, I'm just following it through. I'm going to go back through this one afterwards.
Yeah.
I think.
Yeah.
Thank you.
It's fine.
Right. So this array/list.
Yes.
Right. So we're saying define the function find.
Yeah.
And actually find is in another subprogram called array.
No, so find is the function that we've got. Array is the parameter that's going to be used within that function. So it's what we're going to use. So it's some piece of data we're going to use within the function. And so we then use array here to find out how long the array is. And we use array here to be able to index that array as well.
And we don't define the array until line 8.
So yeah, and the actual array is defined on line 8, and then we pass that array into find as an argument to then be used within the function.
And what does print find words actually do?
So what it should do as we go through is it's going to go through, firstly it's going to ask obviously for you to type in a word, and once you've typed in the word it's going to look through every item in there. So this is creating an index starting at 0 and going up to the length of the array. So in this case it'll go up to 5, and then it's going to say, right, if array I, and hopefully you'll recognize this from when we were doing some string work, that it's about identifying a particular place or a particular position within an array. And so strings are kind of arrays. You can treat a string like an array. You can get a specific value from a string, and we can get a specific value from an array. So the first time through the loop, let's say we've typed in the word computer, just so we find one that is in there. So I will be 0. So we're going to go to look at if array 0, so array 0 is hello, is equal to word, and let's see, I chose computer, so it's not equal to word, so it's not going to do anything, and it's just going to repeat. I will then become 1, and we'll do the same. So is array I equal to word? So is array 1, so array 1 is world equal to computer? No, it's not. So we're then going to go back through the loop, and then we're going to do the same again. So I is now 2. Is array 2, so array 2 is computer, equal to computer? Yes, it is. So then we're going to return this string that I've built, that is the word plus found at position plus the string of I. So it's going to say word so computer has been found at position 2, and that's what will be printed at the end. Does that make sense?
Yeah.
Geeta, I think you had another question. I thought you were about to say.
Sorry.
That's right.
I'm going back a few
No worries.
minutes ago because you talked about this as a really good example for linear search, but you don't
Yeah.
say that. You don't say that to students. And I'm kind of struggling, so maybe sit down and look at it. Is it possible you can show me other examples of linear searches and bubble sort searches, so I can kind of work this into my lessons somehow?
Yeah, I have got some examples. I can't remember if it's something I have already done or if it's something that we will look at. But I will. The plan is, I think it's one of the earlier ones that there are examples of them, and I'm more than happy to share them in some way.
Yeah.
Trying to think.
You're saying this is the linear search because it's going through each one of your range, each one of your items in the range.
Yeah.
Yeah.
Yes. So we're starting at the beginning, we're going through. So yeah, it is a linear search. I said at this point, I wouldn't have been talking to them about it being a linear search. Obviously, I want them to think about it as a searching algorithm. So we'll be talking about the fact that it is searching for something, but we won't actually talk about the linear searches and the binary searches and things until later on. And so that's my plan kind of for later on this half term, is I'll be teaching them about using the linear searches and the binary searches, and look at sorting algorithms as well in there. But yeah, I'll look at a way to share the search and sort files with you or later on today. Okay.
Do you see that the PowerPoints that you use in these sessions?
Yes.
Are these the exact same PowerPoints you use in your lesson?
No, the ones that I use in the lessons are on the OneNote file that I've put on CAS. I don't know if you've downloaded that yet.
No.
So I'll make sure I share a link with it again. But
Can you put the link in the chat here?
I can do. I think I haven't. Funnily enough, I've actually got it open. So in here, that's the most recent version of my Year 9 Prim lessons. It's got up to, I think, last week in there. And so what that is, if I just go, catches up.
I can't. Oh, there's no chat for me. So hang on.
They're not a chat.
Wait. I thought I did have chat before. Oh no. Chat channel in meetings is only available to team members.
You're not a team member. I thought I'd added you. If you just go on the CAS website into their resources, and if you just search Prim in the CAS resources, it's one of the top ones in there. You'll see a mugshot of me, so you'll realise it is. It's called GCSE Prim. But I will share a link as well. I'll put it on the Facebook bit later.
And that has got all the lessons.
So that has got, if I just go into here, so these are all of the lessons from the start of the year that I've done, and it's got everything up until I think my last week's work, which includes things like so you've got string manipulation, and sorry, it's been a little bit slow. So if we go into maintainable programming, so it's got all the lessons set out and all the different tasks. So this is how I do it for the lower ability students, where they don't have the full prim. They'll just go up to modify initially, and they'll do that for 4 activities. And then they do all their make ones at the end, and I also give them some pointers on what they need to do, break it down into English for them so that they can then just do some converting. The middle ability ones, and they have it all, and I just give them some pointers for the make tasks. And then the high ability students, they just get it completely blank. And so, like I said, I've done that. So from right from the start of the year, everything based around programming, they've got that in there.
So hang on. So this, I've never used OneNote before.
Yeah.
So when you're teaching, do you actually show them this OneNote, or do you have a presentation?
So the students have their own OneNote, but there is also a presentation in there, so they can then open it up. So this is one of the presentations. So there's certain things. So we start with a knowledge test. I always have these slides in there just to remind them about the data types and so on, and the concepts or the constructs, because those are really important. This was a maintainable programming one, so I then started to just go through it, and so at this point I just had that, and I'll talk about what these mean and relate it to what they've been doing before this. Then I've got a slide that goes through and just shows some of the key things that are different than what we've done before. So using the def command to create our subprograms, and obviously using the hash to create comments. Then I've got a little bit about subprograms in there, so just reminding them about parameters and arguments and global and local variables. And then I give them an example bit of code. And then I've got a little bit of a diagram that I stole from someone else that kind of shows how the functions will be working as we go through. And then from then it's just a case of they'll just go through and work through those tasks. I'll stop them occasionally just to go through some of the questions in the investigate sections, just to check their understanding and make sure they're understanding what's going on and that sort of thing in there as well.
Thank you.
Thanks.
Can I just ask?
Yep.
Your OneNote. Is it possible to export it as a PowerPoint for the student? Because we use the Google platform. We don't use.
So if you download the OneNote file from the CAS website, it's an editable version that you can then just copy and paste the sections of it that you want. You can export it to different types, but the main ones is Word and PDF if you're looking to export it in a different way. But obviously if you use Classroom, I'd just say take it as a OneNote file and then just copy and paste the bits that you want from it. It's probably the easiest way to do it as you go through.
Perfect. Sorry, my last question regarding these your resources. You've got a PowerPoint for the students to go through. Is that available on CAS as well?
So this PowerPoint? Yeah, that's on the OneNote file. So when I've exported it, if you download the OneNote version, so there's 2 versions on there. There's a PDF version, but if you download the OneNote version, the PowerPoint's included on it.
Excellent. Right. Thank you.
That's all right. Okay. Has anyone else got any other questions or anything?
That is brilliant. Thank you.
So that's about it for this session, but I'm more than happy to go over some bits from earlier on in the session. I might look at trying to re-record what I was talking about on the earlier part. So we've got that bit, but if anyone wants to talk about those, then that might stop me needing to re-record it. So I'm more than happy to talk about anything.
So if I wanted to, not if I want to, because obviously I don't want to, because I would rather be outside sleeping or something. If I wanted homework, I wanted to practice. So if I've just been onto the website and downloaded it, where would I start? So So I haven't done, once you and I have spoken
Yeah.
online, or you've spoken online, I've not really done anything with it. I've just
Yeah.
kind of taken that because
Yeah.
I've been working through the other thing, the future learn thing.
Yeah.
So I've been doing that, trying to get myself, ready for A level with theory. So if I wanted to start somewhere, where on your OneNote would I start? Just if I were, because for me, in year 9, everybody does Python because we have a 2-year curriculum.
Yeah.
So I would want to, I care about my year 9s, but really what I care about is my year 10s.
Yeah.
I want to start them to prepare them to do programming.
Yeah.
Where would I start in this OneNote?
So what my plan is, really with things, is that in year 9 they will do kind of the basics, probably up to kind of the looking at, hopefully kind of a little bit of string manipulation, and a bit of maintainable programming is what I'm looking for as I go through. So my kind of idea is in year 8 they're going to do a little bit, so they'll do the basics of print and iteration and those sorts of things, just at the very beginning. Then in year 9 they'll do kind of a repeat of those ones very quickly, but obviously just going through it a bit quicker because hopefully they'll have a decent understanding of it, and so then hopefully we can get onto some more advanced things. So we'll look at the string manipulation and maintainable programming and things like that.
So you do an 8-week, a 6 to 7 weeks in year 8.
So probably 6 to 7 weeks in year 8, and then I probably want to look at doing a whole term in year 9 as well. And then that then hopefully means that in year 10 there isn't that much more that they need to do, and we can then kind of go over again the very basics, but then focus on things like using arrays, using external files, looking at obviously all the searching and sorting algorithms and how they work, because obviously there's not as much time with a 2-year GCSE. That's kind of the
moving slightly away from today's meeting here. So in the curriculum planning meetings that we're doing, not in this session, in the other bits. So so are you saying, so if I did a half a term in year 8 and a whole term in year 9 for all of year 9s, so that means that's 12 weeks of Python in year 9. So could it be like a half a term, like 2 lessons doing recap from year 8, 4 lessons doing something else that's quite new, and then the next 6 lessons maybe doing like microbit Python, Python,
something like that, just like some project work or something on those lines, just something. I think really it's just about trying to get them to do as much Python as possible before they start their GCSEs, and get them into programming as much as possible, and just trying to condense it as much as you can and just make sure they cover as much as they can in as short time as possible.
So now where I've missed my year 9s completely, that would have been taking the GCSE next year and have done no Python programming at all, and I need to start them from fresh in year 10, would you start them straight into programming in September, or would you say do start the theory?
I would do programming first, so I would look to do kind of as much of it as you possibly can. Maybe you might have to condense it a little bit, so maybe rather than doing 4 activities for each section, they only do 3 activities, so you can just work it through it, and maybe the 4th one is a homework task that they have to do, something like that, just to try and cut it down. So it depends on what you've got time wise, how many hours a week you've got time and that sort of thing. We have 2 hours a week in lessons.
We have 3 50-minute lessons.
So in that case, if you've got 3 lessons a week, then you probably would be all right just to keep it as it is as you go through.
And the other 2 ladies have left.
Have they? Just me and you now. So just going through that sort of thing. So
that lesson was really hard.
Yeah. The one thing I'd recommend is just have a go at doing some of it. You'll start to find it a lot easier if you practice doing it. So even if you just work through some of those activities based around maintainable programming, I think you'll probably find it a lot easier.
Okay.
I know it's obviously extra work and bits to do, but I think the thing with programming is there isn't really a shortcut. Just by listening to people, you kind of understand the terms, but you don't necessarily understand what's going on behind it. And I think you do kind of have to put the hours in to practice coding.
Okay, well, I don't know when I'm going to get the chance to, because I really
Yeah.
So you know the computing in schools
Yeah.
teacher qualification thing,
Yeah.
whatever. So I wanted to finish that off.
Yeah.
Since we never get time to do that.
Yeah.
So I really wanted to finish that off, and so I had to, and I'd registered myself to do a Python course.
Yeah.
At college in June sometime.
Yeah.
Just after term. Obviously they've cancelled it now, and then they said that I could do an online one. I don't want to do an online one. I want to do a face-to-face, go to a classroom and sit down and program a class. So they've cancelled it. So I had made plans to make myself a better programmer. Because you can see, I can talk myself through a program and sort of understand it. I'm just so crap at writing it.
I think that's it. It's just about just practicing as much as you can. Even if you get the odd 5 minutes or so, just doing a little bit of coding, and just like I said, I honestly think that if you were to be able to just work through some of the activities on the prim bit that you've downloaded, it will make you a better programmer. I think it works at all levels. And obviously you've got the guidance initially, and then you can build to work without the guidance and that sort of thing, and just kind of practice it. I know the main thing, it really is time, and hopefully you'll have enough time that you can do things. And I think you, as part of the NCCE qualification, you're expected to do some sort of work. So I don't know whether you can include that as part of what you do outside as well. So yeah, I just do something on those lines.
All right. Well, let's see. All right. Thank you for today.
No worries.
I didn't enjoy it, but thank you.
So it's well, we'll do some file handling next week, and then you'll probably really hate it.
That's really important though as well, isn't it? Is that when you say file handling, you mean like writing to text files and reading from a text file? Yeah, that's really important. So I'll definitely be here. I won't enjoy it again, but I'll be here.
No worries.
All right then, take care.
Okay, bye.
Okay, bye.